Hello students, this is Dr. Munir Omar with CS222 Database Management Systems. In today's lecture, we will study about third normal form and biscored normal form. We can call these as 3NF and BCNF. We have already studied about normalization, the first normal form and second normal form in our previous lecture. These are the contents for today's lecture. First, we will review our previous lecture. Actually, we will recall the first normal form and second normal form. Then, we will move towards the third normal form, and the third normal form is using transitive functional dependencies. So, we will also study this topic. Then, decomposition according to third normal form and the problem resolved in third normal form. After that, we will study the 3.5 normal form, which is called as biscored normal form or BCNF. So, what are the rules for BCNF? We will also look into these. Then, decomposition according to BCNF and the types of decomposition, the loss of information in decomposition, and at the end, we will study about the differences between BCNF and 3NF. In the previous lecture, we studied about normalization. When we design and develop a database, that database might have some sort of redundancy of data in it. So the normalization is a process of removing that redundancy. Redundancy causes anomalies, and if we face some anomalies in a database, then our data would be in an inconsistent form. So in normalization, we decompose tables into some additional tables or multiple tables. Then we have first normal form. First normal form is about the multi-value attributes. In this normal form, we eliminate the multi-value attributes. For each value in a multi-value attribute, we create a new tuple. So each table cell should contain a single value, and each record needs to be unique in the database table. In second normal form, we have some conditions. The first one is that it must be in first normal form, and each primary key column must be in a single form, means that there should be one attribute for a primary key, but this is not essential. The main thing is that we must check the partial dependencies or the hidden dependencies in table. If we have a composite key, then we must check that the attributes in that composite key are not determining any attribute separately. If there is a partial dependency due to a composite primary key, then we must eliminate that partial dependency and create a new table. Now we have a third normal form. For third normal form, we need transitive functional dependency. We have already studied this topic in our previous lectures. If we have three attributes A, B, and C, if A is determining B and B is determining C, then we can say that A will also determine C. Here, according to this definition, a functional dependency A determines C is a transitive functional dependency if there is some set B such that A determines B and B determines C are non-trivial functional dependencies. By non-trivial, we mean that B is not a subset of A. These are separate attributes. Here we have a simple example for this situation. Suppose we have student ID and then we have the program name and the program credits. So if we know the program name, then we can get the program credits. Like for BCS, there would be a number of credit hours. So if we know that this program is BCS, then we can easily get the credit hour offered in BCS. So according to this, we can say that program determines the program credits, or B determines C. And on the other side, the student ID is determining the program name for that student. And according to this rule, we can also determine one additional functional dependencies, that A will also determine the program credits, or if we have the ID of a student, then we can also get the credit hours for that student. So the definition of third normal form is quite simple. The first thing is that it must be in second normal form, and the second thing is that there must not be any functional dependency, the transitive functional dependency. Second normal form plus no transitive functional dependency among the attributes. So a relation is in third normal form if it is in 2NF and no non-key attribute is transitively dependent on a candidate key. Actually, here I talked about the primary key, and you know that a candidate key can be selected as a primary key. So we must take care about this thing, and if there is any sort of transitive dependency among the attributes, then we must remove that transitive dependency and create some new tables. 3NF decomposition. Suppose we have a relation having four attributes A1, A2, A3 and 4. Let's say this is a table having some records about the student. So it will have student ID, student name, student program or program name, and program credits. So in this relation, A1 is determining A3. We can say that A3 is dependent on A1. According to our example, the program name is dependent on the student ID. And there is another functional dependency, that this A3 is determining A4, or the program name is determining the program credits. So we have two dependencies, and due to these two dependency, we have one third dependency, that is transitive dependency, that A1 will also determine A4. So the student ID will also determine the program credits. Now we must eliminate this transitive dependency from this table by the process of decomposition. So what we do, we decompose this table into two new tables. Here we will create two new tables, R1 and R2. In R1 we will have attribute 1, A1, A2 and A3 according to these dependency. Since there was a transitive dependency between A1 and A4, so we will move this A4 to another table, and we will create a new table for A3 and A4. A3 and A4, they have already some sort of association, that is A3 is determining A4. So we have two new tables created from a single table. So this is the process of 3NF decomposition. 3NF is the form which dictates that all non-key attributes of a table must be functionally dependent on a candidate key such that there should be some sort of condition for 3NF that no interdependencies. By no interdependencies, we mean that there would be no transitive dependency among non-key attributes, that there should be no transitive dependencies. For 3NF, we have two major requirements. The first thing is that it should be in 2NF in second normal form. The second thing is that there should not be any transitive dependency among the attributes. So first thing, it should be in second normal form. Second thing, there should not be any transitive dependencies. So here we have an example for 3NF. Actually, this table is not in 3NF now. Here we have a table named as scheme. It has some attributes: title, application ID, book type, and price. So keys are title and publication ID. The composite of title and publication ID is determining the book type. The book type determines the price. Both price and book type depend on a key, hence this is in second normal form. Then what we have transitive here, the title and publication ID is determining price too. So this is not in third normal form. Here we have transitive dependency. The book title and publication ID is determining the book type. The book type is determining the price. So according to these dependencies, we have a transitive dependency that this composite of title and pub ID is also determining the price. So due to this transitive dependency, we can say that this table is not in third normal form. Then we have some examples here. This table is not in third normal form. Here we have three attributes: module, department, and lecturer. Module is determining lecturer, lecturer is determining department, and this module is also determining the department due to these two dependencies: module to lecturer, then lecturer to department. So this module will also determine the department. Now we are going to remove the transitive dependency in this table. This table is in second normal form, not in third normal form, and here we will create two new tables from this table to make it in third normal form, or to remove the transitive dependency. As we know that the module is determining lecturer and the lecturer is determining department, and due to this the module is also determining the department. So we will split these. So what we are doing, we are splitting these associations. The first thing is department and lecturer. So here the lecturer was determining department, so we will create a new table for this: lecturer and department. Then module was determining the lecturer here, so we are going to create a new table for this, so module to lecturer. So these two tables are created from this single table. This is the process of decomposition for 3NF, and in these two tables there is no transitive dependency. Then we have example number 2. Here we have a table having title, publication ID, book type, and price. So the key is title plus publication ID. This is a composite key, and this key is determining the book type. So this is a composite key. It is determining the book type. The book type is determining the price. So according to these functional dependencies, we can assume that the book title will also determine the title and pub id will also determine the price due to the transitive dependency rule. So since there is transitive dependency, so this is not in third normal form, we must decompose this table into two new tables to eliminate this transitive dependency. So what are we doing here? We will split this table. First, book type to price. Here we have dependency between these two, so a new table is created for these two. Then the title plus pub id to book type. This is a composite key, and here we used book type with this because book type was dependent on this composite in our previous table. So these two new tables are created from this single table. What we did, move all items involved in transitive dependency to a new entity, identify a primary key for the new entity. So here we have primary key, and this one is primary key. This was already primary key in our previous scheme. Place the primary key for the new entity as foreign key on the original entity. So here the book type, this one is actually the foreign key, and with the help of this book type we can connect both the tables. Then we have example number 3. Here we have 3 attributes: the building ID, contractor, and fee. Primary key is building ID. Building ID is determining the contractor. So this is the relationship between building ID and contractor. Then the contractor is determining the fee, and due to these functional dependencies we can assume that building ID is also determining the fee. So we have transitive dependency here, and we need to split this table into two new tables to eliminate this transitive dependency. This is the old scheme having 3 attributes. It has transitive dependency, so we will remove this transitive dependency by creating 2 new schemes. So in the first scheme we will have building ID and contractor due to this dependency, and in the second table we will have contractor fee due to this dependency. And here this contractor is actually the foreign key which can be used to connect both the tables. Primary keys are building ID and contractor. Then example number 4, we have a table having studio ID, studio city, and city temperature. So if we know the studio ID, then we can get the city of that studio. So studio ID is determining the studio city. If we need the temperature of a city, then definitely we must know that city too. So if we know the studio city, then we can get its temperature. So the studio city is determining the city temperature. So if there is a relationship among these attributes in this way, or simply say that there is a functional dependency between these attributes, then we can get the transitive dependency, that if we have studio ID, then we can get city temperature. So this transitive dependency must be eliminated. So for this elimination we must decompose this table into 2 new tables. So what will we do? We will create 2 new schemes or 2 new tables, and there would be no transitive dependency. So studio ID determines studio city, so create a new table for this. Then studio city determines the city temperature. So create a new table for this. And here in these two new tables, the studio city can be used to connect both the tables. So here the studio city is foreign key and the primary keys are studio ID and studio city. Problems resolved in 3NF. In second normal form, there were some problems. The first one was about insert, like we were not able to add lecturers who teach no module. It was not possible for us to add a lecturer who is not teaching any module. Like here, I cannot add L5 without any module. Module is primary key here, so it was not possible for me. Then update. To change the department of L1, we must alter 2 rows. Now, if you look into this previous table, if I'm going to change L1's department, then I must execute an update query twice, or two separate update queries for these two tuples. These are actually anomalies due to second normal form or due to transitive dependency. The third was about delete. If we delete M3, then we will also delete L2. Means that the entire record will be deleted. So if here this module is over and we delete it, what will happen? This lecturer will also be deleted from the records. So the record about lecturer 2 or L2 will be deleted and we will have no such record about this lecturer. And actually our intention is to delete the module, not the lecturer, but this will be deleted automatically. So this was an issue in second normal form, and these issues are resolved in third normal form. Now here we have two separate tables, and if we apply these operations on these tables, there will be no anomaly or no loss, no data inconsistency. But still, the 3NF may have some anomalies because this is not the final form of normalization. We will discuss these in coming slides.